Welcome to the presentation on my coursework for the Managing Machine Learning Projects course offered by Duke University. I am Suhas KU and I'll be walking you through my project work here. Let's see what we will be covering. First, I will introduce you to the problem or the opportunity. Then we will evaluate it. Then we'll look at the CRISP DM business understanding steps, solution concept and validation plan, followed by the design of machine learning system, and lastly, the potential risks in the production. Okay, the problem statement. So I have decided to work on a fascinating problem here, that is to interpret a dog's language. The goal here is to build a system that can accurately recognize, distinguish, and interpret different vocalizations and behaviors like barks, growls, whines, body postures, and facial expressions of the dogs. This is with an intent to figure out their emotions, needs, and intentions. The main idea behind this project is to improve communication and understanding between dogs and humans, ultimately enhancing our interactions and the well-being of our pet dogs in different situations. Now let's evaluate this opportunity. The real question is the problem real? When a dog barks and wags its tail at us, how many of us know what it really means? Does it mean it is hungry, or does it want to play with us? Or is that a warning or a threat? As owners and animal lovers, we often develop an intuitive understanding of dogs' needs and emotions based on their behavior and reaction. This is merely based on our own observations and experiences with dogs rather than a systematic language that can be decoded like English. So the interpretations vary depending on the situation, individual's differences, and the dog's breed or its emotional state for that matter. So yes, the problem is real and we do not always understand them correctly. So the next question is, can ML help us solve it? I know it's a complicated problem, but it is feasible with machine learning when combined with computer visioning, vocalization, or sound recognition, and maybe a bit of NLP as well. So do we have the data or can we get it? Historical data from animal researchers, expert interview, and questionnaire survey on dogs' behavior studies like face expressions, body language, sounds can be gathered and used for training our model. Right? So we can also get some live data from our home or phone cameras and audio devices which can help capture the data and also perform object recognitions, classification to identify the gestures, sounds, and various poses. This, when combined with potential contextual data derived from human interactions like playing, eating, time of the day, etc., these could be used as a input feature for us. Right? And who really cares about this? There are several beneficiaries of this ML system like dog owners, dog lovers, for instance. It could also help us build strong bonds with dogs, help animal researchers and welfare organizations in behavioral studies. Individuals relying on service or aid dogs to cope up with their disabilities can benefit from better communications, enhancing the capabilities of the canine units in police or military settings through better understanding of their canine partners. Now let's dive into the CRISP DM's business understanding. Here we will be defining the problem, the success criteria, and identifying the factors. First, let's look at the problem. So the target users are potentially the pet owners, dog trainers, canine team, veterinary doctors, welfare organizations, and researchers. Problem statement is accurately interpreting the dog's emotions and messages by analyzing their vocalizations and body language cues, combining with the context data. Why it matters, right? So improper communications and misinterpretations of dog signals often leads to unwanted or unexpected responses from us humans. This could result negatively, right? So next question is, how do we solve it today, right? It's mostly, as we know, it is by intuition, our understanding of the dog's needs, emotions, which we have gained by observing their behavior and reactions for several years. What are the gaps? The gaps could be you can only understand the dog when you have built sufficient trust with it, or you'll have to do some positive reinforcement and pay a lot of attention to really grasp what it wants. Next, let's define the success criteria. What is the expected impact? So we want to improve the dog and its owner's understanding. We want to build a strong bond between the uh, dog and the owner so that each others can fulfill their needs. Next, the output metric. Output metric here, I have defined the pet owner's happiness index as one of the output metric, and the other would be to assess the dog's health. So which could be as number of veterinary dog visits which is scheduled. So we target to reduce those values and increase the happiness index. So the output metric here is this is basically a classification model mainly. So I'll be using the accuracy, confusion matrix, and area under the curve for ROC curves, right? So target values is simply to increase the happiness index of the pet owners by a percentage, 30%, and also to decrease the veterinary visits for the dog. Constraints are uh, it only works for the pet dogs which are grown in a loosely controlled environment. It cannot be applied for stray dogs or other canine animals. Dog communication is not as simple as human language. It is not a systematical language, so it requires a lot of interpretation has to be taken with a pinch of salt. So next, let's look at the identifying factors. So let's identify the factors. The factors here could be the dog's age, its gender, breed, what are the body postures, some of its facial expressions, the sounds such as barking, howling, and so on, its current emotional state, the context in which the behavior has been shown, and the time of the day to identify certain patterns. So we have gone through all the three questions, answered them. Next up, let's look at the solution concept. The concept is simple. We want to develop an ML model to interpret the body language of the dog along with its vocalizations and facial expressions under various contextual situations. So we will be training a model on diverse, large data set, which is well labeled, which contains the dog's behaviors, that includes its sounds, which we have already discussed, facial features, expressions, so on. We'll also have to combine this with its corresponding emotions that is expressing, like whether it is happy, like wants to play, or is it showing anger, aggression, and combine this with our contextual situation to get a better interpretation of it. So the target variable here will be the interpretation of the dog signs. The values for this variable would be in a short phrase manner, like um, need food, like to play, or showing some pain, or giving some alerts to the owner. So the feature engineering, if we look at it, so we will be grasping the features from audio signals, images, video recordings, some textual representations from the dog behavioral studies, and the model will be designed to handle multimodal inputs to gain a comprehensive understanding of this dog communication language. So ML model won't truly understand the dog's language like we humans do, because it is not a very systematic language. But the goal here is to provide an insight into the behavioral patterns and emotions just to enhance the human dog communication and to assist our pet owners in understanding their dogs' needs and fulfill them. Next, let's look at the validation plan. Right? It is essential to have a proper validation plan. So here we will be splitting the data gathered via interviews, questionnaires, survey, research studies, and other sources into training and validation set. And for this particular model, we will be reading a large data set. So we will have to manage with whatever data we get. So I'll be employing the cross validation methods to maximize the use of it. So the iterative process that I'll be employing is first I'll have to create a prototype. Initially, this prototype will be a mock-up of the potential solution. Later on, this will be enhanced and expanded to add more features and identify the feature importance and also get an expert interpretation of it. Later, a real ML model will be developed and tested on the real world data in a supervised learning model, and experts will be validating the output and its interpretation. It will further be improved by adjusting the weights, creating multiple models and versions with the goal of improving the performance on a larger data set. Finally, we'll refine the model to add more relevant features and interpret the dog signs. The iterative approach will continue with the goal of improving on the crisp DM steps until we get a satisfactory performance. Finally, the final model will be selected and deployed on production. The app will also uh, provide the users to continuously give feedback by sharing their interpretations on the dog's actions. This can be used to monitor the ML model's real world performance and decay rate also. Um, so we will be seeing at this at a later stage. Let's jump on to the next topic. which is designing our ML system. So the ML system is mainly designed on the three criteria as listed here. We will have to pick and choose between this. Let's debate on the cloud versus edge topic now. So in this case of interpreting the dog's language and arriving at a conclusion, does latency really matter? Right? So instant interpretations and predictions are required to respond quickly to the dog signal. So that is a prime consideration. And ML system should be capable of interpreting and predicting irrespective of the internet connection. At times, the dog and the companion might be in a dead zone, which would still need to read the dog's actions, right? So when the internet is available, we can have a better online predictions. If it's not there, then the already predicted values matching with the similar situations and cues should give a close to uh, near accurate values. So when it comes to sending the data to the cloud, there is always a security and privacy concern uh, because it involves a lot of home footages, videos, conversations between the humans and the dogs. So this, considering all this, we will need a hybrid approach, and this is my take on it. So we'll be initiating the cloud ML through trigger generated by the edge AIs, store common pre-computed predictions on device to give a more quicker and less latent with minimal latencies even when the internet is not available. And we'll be exploiting many local center servers to minimize the latency as well. So next, let's look at the learning aspect of it. So here, uh, online learning would be the best option for the reasons listed below. Firstly, the continual retraining. As new data arrives, we would have to retrain with the new data points, like the new contextual situations or the user feedbacks on dogs' actions and signal interpretations. Right? And it also requires real-time adaptation. So changes with new situations or events, dogs might behave differently in different new situations, or could it be like a birthday of a owner or a family member where it would show a lot of excitement and it would be quite jovial than usual days, right? So the adding the context and the conversation uh, would also bring in new interpretations for the same signs. Or it might also sometimes show pain or would be sick, and that would have a different interpretation of it. So all this requires a large and complex data set which can only be handled with online learning. Next, let us look at the predictions. Again, here it would be the best suited to go for the online prediction, as the dog owners and the users of the application would require immediate predictions and translations of the dog's actions and language, right? And low latency is again a concern. So we'll have to deliver it as soon as possible for any actions and responses to be provided by the users. So that's for the three design aspects of it. Now let's look at the potential risks in the production. I have primarily identified four different risks, and let's look at them one by one. The first one is the training versus serving skew. In this case, the dogs exhibit diverse behaviors in real world situation. It is hard to train our ML model on all the possible scenarios because it is impossible to anticipate all the real world situations and the dog's behavior in such cases. So we are still not there yet, but yeah, I anticipate to see this skew in the production. Next, let's look at the data drift. So as the dogs grow older, the sounds they utter changes. The barks become louder, the, they start to learn new types of sounds. We have also seen certain dogs which can mimic the sound of the human beings. And their expression also varies, which may bring in new and unanticipated values for the input feature. This can impact the model's ability to accurately interpret new patterns, leading to potential misinterpretations of the dog's behavior. So that's another risk I see. So thirdly, there is a concept drift which might happen. Looking at the dog's ways of communicating and the emotions they convey, they might even evolve over time due to several factors. The example that mentioned, I have seen a video where a dog says "I love you," "hello," oh to the human beings and the owners. So this challenges our model's generalization abilities and requires regular updates to adapt to such new patterns. And lastly, there could be certain model biases because the data set may be skewed towards a specific dog breeds or behavioral patterns that are prevalent in certain regions only. So that's for the four potential risks in the production. Now let's look at what we have seen so far. So firstly, we evaluated the opportunity or the problem, how the ML can help and what data to use and who will be benefiting or does really someone care. Secondly, we have dived into the CRISP DM business understanding step, defined the problem, what success really means, and identified the contributing factors. Next, we also looked at the solution concept, the iterative approach for modeling and validating our ML model in version and deploying to the production. Later, we explored the design aspects of ML system to interpret the dog signals and communications. Here, the hybrid of cloud and edge was found to be best suited for our case. Also, I decided to go with the online learning and delivering online predictions. Finally, we have touched upon the potential risks, uh, the four potential risks that we have seen recently, and that's what we have covered. Yeah, thank you for being with me. Yep, we are not there yet, but hopefully one day we will understand our canines and other species better. Of course, with help of ML, neural networks, and whatnot, right? So, thank you. Bye.